In 2005, the year Hurricane Katrina hit New Orleans, the average 48-hour track error on hurricane predictions was 110 nautical miles. That means 2 days before a hurricane made landfall, our prediction of where it would hit was off by about 125 statute miles. That's the distance between New Orleans, Louisiana, and Pensacola, Florida. In 1990, that distance was 200 miles, and today it's about 65. So what changed? 200 to 125 to 65 in 25 years. Yes, meteorology has gotten more sophisticated, we have better satellites, but there's one specific tool in forecasters' toolbox that gets exponentially better every single year that more than anything else has played a tremendous role in saving people's lives in this way, and it has to do with make-believe. All over the world today, there are big supercomputers whose job it is to pretend to be storms. They can tell us how they'll move, how they'll strengthen, how they'll weaken, and every single year these computers get bigger, faster, and therefore better able to pretend, within the parameters assigned to them by the forecasters, to be those storms. Technically we call it simulation and modeling, but it's really about making the computers pretend. I know it sounds like a little bit of a play school word, but why use a $5 word when a 50-cent one will do? We make the computer pretend. And when we have the world's biggest, fastest supercomputers available to us, the power of make-believe may be beyond what even Mr. Rogers taught us. There are a lot of very interesting things happening in this world that are either too big or too small, too fast or too slow, or too dangerous or too expensive in order to see with our eyes and touch with our fingers. But we can watch the computers pretend. So hurricanes are big and dangerous. What about something small? Our bodies are partly made up of proteins, and they perform a lot of important functions. But in order to function, they have to assemble themselves or fold into certain shapes. There's a lot about protein folding in the body that we don't yet understand, but we do know, or at least suspect, that when this process goes wrong, we have things called proteopathies. Think Parkinson's or Huntington's or Alzheimer's or Creutzfeldt-Jakob. We would love to have the ability to watch these proteins fold and misfold inside the body, but that's just not practical. Now we do understand most of the physics and the chemistry involved, so what we can do is instead make the computer pretend. Look what it does when it pretends to be those folding proteins, find the critical moments where things go wrong, and we can use that knowledge to suggest possible drugs that could help. The rules and outcome of the game need to be set by very smart experts in this field, but it gives them an incredible capability that they wouldn't otherwise have. How about something expensive? In 2003, Goodyear, the largest tire manufacturer in the United States, was in trouble. It took them 3 years to go from product inception to market, and the development process was largely educated guesswork. They'd draw a tread, they'd manufacture it, they'd test it and repeat until they had something marketable. That year they made a decision that may have saved their position in the market. Stop doing, start pretending. They used supercomputers and made them pretend to be tire treads on sand, on pavement, on mud, on water. The result was that 3-year cycle was reduced to a 1-year cycle. Building tires went from 40% of their R&D budget to 15%. 3 years later they posted record profits. How about something slow? Computers can pretend to be the Earth too, but not yet all of it. Climate change is one of the critical issues of our time, and computing lets us look at how our choices today affect the future. We can model the atmosphere and make computers pretend over decades and centuries as we tweak carbon or methane or ozone or ash, but there aren't enough computers in the world today to turn as many of those knobs as fast and in as many combinations as we'd like. But we're on our way. And the day will come when countries of the world can come together and negotiate climate treaties, armed with computers powerful enough to pretend to be the planet, and know quickly and confidently what the decisions they make that day will mean for the future of the Earth. A lot of human effort is spent trying to understand how the world works, to predict the unknown or the unknowable. And faced with the unknown, we have some choices. Doing is important, but we can also pretend. Remember that folding protein problem? You can use your PC or even your phone to join a worldwide network of computers working together to solve that problem. It's called folding at home. There's lots of other projects too, and I hope you'll take a look at some of them and maybe join when you get home. Because when experts set the rules of the game and let loose computers to play pretend, the results can change the world. Thank you.